Giving a model tools is easy for one app and one tool. The mess starts when every AI application has to build its own custom integration for every system. Your files, your database, GitHub, Slack, on and on. The Model Context Protocol (MCP) exists to end that mess. It is an open standard that lets any AI app talk to any tool through one common interface, the way USB-C lets any device charge through one port. Over the next few minutes, we unpack what MCP really is, its client and server architecture, the three things a server exposes, and why a boring standard is quietly a big deal. Picture the world before a standard. You have several AI applications and many systems you want them to reach. If every app builds a bespoke connector to every system, you get a combinatorial explosion. The number of integrations multiplies, and each one is custom, fragile, and maintained separately. Build a clever GitHub integration for one assistant, and none of the others can use it. This is the classic M times N problem. A standard collapses it into M plus N. Each application speaks the protocol once. Each system exposes itself through the protocol once, and suddenly everything connects to everything. That collapse is the entire point of MCP. MCP is an open protocol, a shared agreement on how an AI application and an external tool talk to each other. It is not a model, not a framework, not a product. It simply defines the messages, how a tool announces what it can do, and how the application asks it to do those things. Because it is open and standard, a tool built for MCP works with any application that speaks MCP today and tomorrow. No custom glue per app. Under the hood, it uses JSON-RPC, a simple, well-established format for sending structured requests and getting structured responses. Nothing exotic. The power is not in the technology, it is in everyone agreeing to use the same one. MCP has three roles. The host is the AI application the user interacts with, your chat app or coding assistant. Inside the host runs one or more clients, and each client holds a dedicated one-to-one connection to a server. The server is a separate program that wraps some capability, your file system, a database, an API, and exposes it through MCP. So the host might run several clients at once, each connected to its own server. One for files, one for GitHub, one for search. The host orchestrates, the clients carry the conversation, and the servers do the actual work. Clean separation with the model sitting in the host deciding what to call. A server can expose three kinds of things. Tools are actions the model can invoke. Send an email, run a query, create an issue, for example. These are functions with described inputs, and the model chooses to call them. Resources are data the server makes available for context. A file's content, a database record, a document pulled in to inform the model. Prompts are reusable templates the server offers, pre-written workflows a user can trigger, like summarize this repository. The distinction matters. Tools are model controlled actions. Resources are application controlled context, and prompts are user controlled shortcuts. Most of the attention goes to tools, but resources and prompts are what make a server genuinely useful. Let's walk through one interaction. When the host connects to a server, it first asks, "What do you offer?" And the server replies with its list of tools, resources, and prompts. The host hands those tool descriptions to the model. You ask a question, the model decides it needs a tool and emits a structured call, which the client forwards to the server as a JSON-RPC request. The server runs the real action, talks to the actual database or API, and returns the result. The result flows back into the model's context, and the model uses it to write your answer. Discovery, then call, then result, then response. The protocol standardizes every arrow in that loop. MCP supports a couple of transports, the channel the messages travel over. The simplest is standard input and output, used when the server runs as a local process on your own machine, which is perfect for accessing local files or tools with no network involved. For remote servers, MCP uses HTTP with streaming, so a server can live on the internet and serve many clients, sending results back as they become available. Either way, the messages are the same JSON RPC, only the pipe changes. This is why an MCP server can be a tiny script on your laptop or a hosted service for a whole company without changing how the model talks to it. Handing a model real tools is powerful and genuinely risky. So security deserves real attention. An MCP server can run code and touch your data. So you should only connect servers you trust, the same care you would give any software dependency. Two dangers stand out. First one is permissions. A server should get the narrowest access it needs, and risky actions, deleting data, spending money, deserve an explicit human approval step. Second one is injection. A tool's results or a resource's contents are untrusted text that could contain instructions trying to hijack the model. Treat tool outputs as data, never as commands. The protocol gives you reach, using it safely is still your responsibility. Step back, and the real value is the ecosystem. Because MCP is open, anyone can publish a server and it instantly works across every application that speaks the protocol. Write a connector for your internal system once, and every compliant assistant can use it. Reuse replaces reinvention. This is the same story as past standards. The boring agreement, USB, HTTP, and the language server protocol ends up mattering more than any single clever product because it unlocks a whole market of interoperable pieces. MCP is young and still evolving, but its bet is that the future of AI tools is not one company's walled garden. It is a shared, open port everyone can build on. So that is MCP. It exists to kill the M times N integration mess, turning it into M plus N with one shared protocol. It is an open standard, not a product, built on simple JSON RPC. A host runs clients, each connected to a server that exposes tools, resources, and prompts. The model discovers what is available, calls a tool, and gets a result and answers over local or remote transports. Connect only servers you trust, gauge the dangerous actions, and treat tool output as data. Get that right, and any model can plug into any system through one port. Let me know if you have any questions in the comment. I hope I was able to give you some information about how MCP works.